Welcome to my channel Worldwise. Why are there not more people talking about the mysterious surge in methane that began in 2006? In 2006, something unexpected happened in Earth's atmosphere. Methane levels, which had been stable for years, suddenly began to rise, catching scientists off guard. Scientists worldwide noticed the same alarming trend. Methane was surging and fast. The data was consistent across continents, leaving little room for doubt. This wasn't a minor fluctuation, it was a sharp, sustained increase that broke the calm of the previous decade, signaling a dramatic shift in atmospheric behavior. The scientific community was jolted. Methane, a potent greenhouse gas, was on the move and no one knew why. Theories began to circulate, but answers were elusive. The data was clear. A new chapter in Earth's climate story had begun, and it was urgent. The stakes had never felt higher. Methane's spike sent shockwaves through climate science. Its potency meant even small increases could have big impacts, amplifying global warming far more than carbon dioxide. Was this a temporary blip, or the start of a dangerous trend? The questions multiplied, and so did the urgency to find answers. Scientists raced to uncover the source, knowing the planet's future could hinge on the answer. Every moment felt critical. The rise didn't slow, it accelerated year after year, signaling a global shift that demanded immediate attention. The steady rhythm of methane had been replaced by a rapid, unsettling beat, echoing through the scientific community. The world's experts faced a climate mystery. The signal was clear, but the cause was hidden, buried somewhere in the planet's complex systems. The search for answers became a top priority, uniting researchers across disciplines and borders. The calm of atmospheric monitoring was gone, replaced by a high-stakes investigation, with every new reading adding to the tension. Each year brought more methane, deepening the mystery and raising the stakes for humanity's response. The Earth itself seemed to be breathing differently, and the implications were profound, touching every corner of the globe. Scientists had a signal, but the culprit remained elusive, hidden in the vast web of natural and human influences. The hunt for answers had truly begun, setting the stage for one of climate science's most urgent investigations. Methane is a simple, invisible gas, 1 carbon, 4 hydrogens, but its impact is massive. As a greenhouse gas, methane traps heat far more effectively than carbon dioxide, over 80 times more in the short term. Though it breaks down in about a decade, its immediate warming effect is intense. The recent surge means a rapid, powerful boost to global warming. Scientists use ground stations, aircraft, and satellites to track methane spread. The post-2006 spike was global, revealing that something big had changed. This surge is an urgent climate challenge, amplifying the warming we already face. To grasp today's methane spike, we look to the past. Ice cores from Antarctica and Greenland preserve ancient air. These records show methane rising and falling with the planet's great climate cycles. During ice ages, methane was low. As the world warmed, it rose, amplifying the transition out of deep freezes. Wetlands, thawing in warmer times, released methane, fueling a feedback loop of warming. This natural rhythm played out over thousands of years, tied to slow planetary changes. The ice cores are our baseline, showing what's normal for methane. Large spikes meant major climate transitions, until now. Today's rapid surge doesn't fit the ancient pattern. We live in the Quaternary period, a remarkable era marked by repeated cycles of ice ages and brief, warmer interludes. These dramatic shifts have shaped the landscapes and life on Earth for millions of years. The Holocene, our current warm period, began about 11,700 years ago, allowing human civilization to flourish and nature to thrive in more temperate climates. These cycles are driven by Milankovitch cycles, subtle, predictable shifts in Earth's orbit and tilt that change how much sunlight reaches the planet's surface over thousands of years. When less sunlight hits the north, vast ice sheets grow. When more arrives, they melt, exposing darker surfaces that absorb heat and accelerate the planet's warming. Thawing wetlands then release methane, a powerful greenhouse gas, amplifying the end of ice ages and speeding up global warming. This feedback loop is a natural part of Earth's climate machinery, operating like clockwork over vast stretches of time. For hundreds of thousands of years, these cycles have set the pace of warming and cooling, leaving their mark in ice cores and ancient sediments. But today, something new is disrupting this ancient rhythm: human activity, which is altering the climate faster than ever before. According to natural cycles, a major methane spike should only happen at the end of a long ice age, when the planet is slowly warming after millennia of deep cold. But the current surge began in 2006, far too soon, and far too fast for what we'd expect from nature alone. The Earth isn't emerging from a deep freeze. It's already warm, with landscapes that should not be releasing this much methane. This anomaly suggests a new force is at work, overriding the slow, predictable cycles of the past and introducing new uncertainties. Scientists are alarmed. The feedback loop that ends ice ages seems to be activating now, but in a completely different context than before. Human-driven warming is melting ice, exposing dark surfaces, and possibly triggering more methane release from permafrost and wetlands. The timing is wrong for a natural event, pointing to modern pressures like industry and land use as the likely cause. The challenge is to pinpoint what's changed so dramatically since 2006, and why the spike is accelerating now. The broken rhythm is a warning. Earth's system is reacting in powerful, unexpected ways, and the consequences could be profound. Scientists are now detectives, tracking methane sources with advanced technology. Human activities, fossil fuel extraction, agriculture, and landfills are major contributors. But the sudden post-2006 surge hints at more than just increased human emissions. Natural sources, especially wetlands and thawing permafrost, are under scrutiny. Satellites now reveal methane plumes from both industrial sites and vast wild landscapes. Thawing Arctic permafrost is especially worrying. As it melts, ancient organic matter decomposes, releasing huge amounts of methane. This is a tipping point, a self-reinforcing cycle that's hard to stop. Unlike industrial leaks, we can't simply plug these natural emissions. The awakening of these carbon stores could reshape our climate future. The methane surge since 2006 is one of climate science's biggest mysteries. If it's mostly from sources we control, we can act quickly and see results. But if natural feedbacks are now driving the rise, the problem is far harder to solve. We may have triggered a runaway process, pushing Earth out of its stable rhythm. Methane spike is a warning. Our planet is responding to pressure in unpredictable ways. The future pace of warming may depend on how this story unfolds. Solving the methane mystery is urgent, not just for scientists, but for all of us. The stability of our climate and our civilization may depend on what we do next. My next video is watching now.